guys. Apologies for that. We had an unexpected occurrence here, but I cut the video there and we'll just continue on to where we were. So this is part 3 of the week 11 Math 1031 Georgian College video here. And just to recap, we were looking at drug abused youths and hospital visits, right? And we just looked at question 1, right? Which 0.1 times 0.4 gave us an answer there of 0.04, okay? And that was drug abused and hospital visit, all right? Number 2, what is the probability that a randomly selected youth was not admitted to hospital? So this is anyone, drug abused or not, went to the hospital, right? And you just multiply these up. 0.1 times 0.6 plus 0.9 times 0.85. Do the mathematics and you get a probability of not going to the hospital. Remember, that was the complement of going to the hospital, right, is an 82%. So in fact, 17.5%, there's a 17.5% chance of randomly choosing a youth there that has gone to the hospital. So, and we just figured out there that what is the probability the randomly selected youth was not admitted to a hospital given they had abused drugs? Okay, so they only one path to go, abuse drugs on this side here, and then we're not admitted to a hospital. There's your complement, right, 60%. Okay, so now you're going to see there that question 4 is kind of, we've already answered a lot of question 4 already, and it's going to be just kind of like plug and play here. But what you have to acknowledge here is that there's a little bit of a difference in English. And you have to be able to recognize this, because what is the probability that a randomly selected youth abused drugs given they admitted to a hospital? Whenever you see that given, okay, it's you've got to do things this way here, okay, because you're kind of comparing, okay, one to another. So in order to find the probability of drug abused, okay, with respect to hospitalization, we may use a rearranged multiplication rule. Okay, there you go. And you can rearrange this, go back and have a look, and you will see there that you have seen this there before in this particular question. If you go back to question 1, you already have that answer. If you go to question 2, okay, you found the complement of that answer. Okay, so you just have to subtract from 1. So from question 1 there, we already have the numerator. Okay, what's the probability there of drug abused and hospitalization visit? Sorry, I'm just trying to get the numerator. And we calculated that to be 0.04. Okay, so that goes 0.04. We may find the denominator directly, but it's easier to use this complementary probability. If you go back there to question 2 of this same question, youth being drug abused and hospital visits, if you go back to number 2, we found the complement that there, what was it there? Randomly select a student or a youth and them not going to the hospital, 82.5%. So we want to find the probability of going to the hospital, so that would be the complement of that, complement of the complement. How's that one? And so we have 17.5% or 0.175. So now what we just do is we plug and play. And we found that to be 0.04. We found this there to be 0.175, right? Percentages, 4%, 17.5% is equal to 8 over 35, which is equal to roughly 22.9%. So we can interpret this result as that among all youths admitted to a hospital, only about 23% were because of drug abuse, and the other 77% were for some other reason. Okay, so an interesting study of how you can isolate congregate, how you can lump things together. You can just view things differently. And yeah, it's very important when you're talking, billions of dollars a year being spent on OHIP, where you guys are all going to be there soon, working within, OHIP and getting paid by OHIP, right? Nurses, PSWs, all, you know what I mean, the whole lot. And it's all about contact time. And if there is a certain group of people who are utilizing more of the system than others, then that puts strains and, could eventually cut services. Important study. Interesting. The last part of week 11 here, we'll finish this up there in a couple of minutes, are these contingency tables, which is the method of displaying a summary of the values, frequencies of two variables in a sample space. And you'll see there that you have parameters along the top, parameters along the left-hand side, right? So here we're talking about that represents a contingency table that represents the number of pets hospitalized in a vet clinic during the summer. So here are my summer months, June, July, and August. Okay, and here are cat and dog. So there was 12 cats serviced at the vet, 6 dogs serviced at the vet for the month of June, totaling 18 animals in total. Same was done for July, August. So our total number of animals is 50, 30 cats, 20 dogs, 15 processed in August, 17 in July, 18 in June. So you can kind of see here, these are nice. Okay, they lay it all out for you. And again, you can answer questions there like these. If a pet is selected at random from the sample represented above by the contingency table, is it a cat? Is it a cat hospitalized in June? Is it a dog? All these kinds of different questions there that we can isolate and answer. These are not so bad. So, what's the probability there of choosing a cat? Well, you've got 50 animals total, right? The number of desired divided by the total. 30 divided by 50, which is 3 divided by 5, which is a 60% chance of choosing a cat. What's the probability of choosing a cat hospitalized in June? Well, that would be 12 divided by 50, 24%. Probability there of choosing a dog or hospitalized in June. Okay, now you see. So all the animals hospitalized in June will be 18, right? Okay. And dogs are 20. So that's why I have 20 over 50 plus 18 over 50. But have a look here. You have overlap. You have 6 dogs that are in this row being counted, but you also have 6 dogs, the same 6 dogs that are in this row. So you have to subtract 6 from this total. So 38 minus 6 would be 32 over 50, right? And then find the percentage. So there's a 64% chance, okay, of choosing a dog or an animal hospitalized in June. Okay. Last slide. Thank goodness, a bit of a long one there today. What's the probability there of choosing a dog given it is hospitalized in June? So, what did I just do there? There we go. So, the whole idea here is what we've got. Dog, in July. Okay, is the dog given there? It's hospitalized in July. So, there's your dog for July. There is total animals for July. You notice there that we're not using 50. Aha. Right? Because we're only talking about July, which is an important statistic on its own, right? How many dogs are we processing in July alone, right? You wouldn't take the 50 because that's including their 3-month study, right? Okay? If you're only talking about July, then you would only use 17. Probability there is hospitalized in July given it is a dog. Okay, in this case here, Okay, you have 7 because there's 7 dogs in July. That's it. Okay, and divided by the total. So here, 7 divided by 20. Okay, yeah, it takes some getting used to. Have some fun with this. I hope you guys are doing all right. Please let me know if you guys are having any issues. Shoot me an email, and we'll get you guys through. Take care, everybody. Apologies there for the 3 videos, but it's the way we got to do it. Thank you. Take care and be well.